At the site of vessel injury, the first platelets arrive to start sealing the wound. Simultaneously, the coagulation cascade with its various coagulation factors is activated. This involves two pathways, the extrinsic and the intrinsic pathway. Extrinsic activation begins with now exposed molecules of the vessel wall, such as tissue factor, which forms a complex with factor 7. Finally leading to the activation of factor 10. This factor 10A is the point at which the extrinsic and the intrinsic pathways of the coagulation cascades meet. The intrinsic pathway consists of various coagulation factors activating each other in a chain reaction. At its end, a complex with an additional cofactor is formed. This complex now activates factor 10. Since the two pathways merge at the level of factor 10A, this factor has a pivotal role in the coagulation cascade. Further down the cascade, factor 10A in combination with 5A activate thrombin and induces the so-called thrombin burst. One molecule of factor 10A can catalyze the formation of 1,000 molecules of thrombin. These large amounts of thrombin cause the further activation of platelets and the enhanced formation of fibrin. Fibrin then forms strands, making up the mesh that stabilizes the platelet plug in an arterial clot and holds together the red blood cells in a venous clot. It can be concluded that the central role of factor 10A in the coagulation cascade makes it a viable target for therapeutic intervention in pathologically altered blood coagulation.